Only Martin has connected to the audio. Okay, no problem. What we can do now. Okay, so we will discuss today the conductors and the insulator. In the last class, what we have discussed? Introduction. I have told you electric charge. Two types of charge are there, positive charge and the negative charge. Okay, so two negative charge or same charge will repel, unlike charge will attract. Unit of charge, SI unit of charge is coulomb, and we have defined the 1 coulomb also. In matter, atoms are there, nucleus is there. This is the nucleus, this is the atom. So at the center there is nucleus, and around it the electrons are revolving. So in atom, protons and electrons are there. There are neutrons also, but they are neutral. So in electron have the negative charge of this, and in nucleus there are neutrons and protons. So neutrons are neutral, no charge, but protons have the positive charge. So today we will discuss the conductors and the insulators. So conductors and insulators, you can see this is the cable. Abdullah, now getting my voice? And Hamna, if you
Yes,
are not, yeah, okay. Hamna, if you are not, means if your mic is not working, you can just write in the chat box. And Aman, if you are not getting, means your microphone is not working, you can also write in chat. Aman, are you getting my voice? Aman and Hamna, you can write in the chat box.
yes, sir.
Okay. Okay, so see, these are some pictures here. Uh, this is the copper wire, and this is the cable. This is the cover of the wire. Okay. You can see here also. This is the mouse, and this here is this cable, means cover above this, and inside this there will be a wire. The wire can be of aluminium also and can be of copper also. So basically this is an electric cable. This is an electric cable containing 3 insulated copper wires. So electric cable, so what is the use of this electric cable? You have seen in your home also. Basically these copper wires or the metals, you can say, in these the current can flow. The current can easily flow. You have also seen this kind of plug in your laptop charger or any other kind of charger. So basically these pins made up of metal, these are the metal pins, and this is the plastic cover. This plastic is the insulator. Insulator means in plastic the current cannot flow, but these are the metal pins. Through this metal pins the current will flow through the plug, and this plug will be connected to somewhere else. So conductors and into insulators are there. Conductors and insulators are there. So here this is the insulator, this plastic case is the insulator. And why this is the into insulator we have made? Because if this plastic case will be conducting, so uh, when you will just touch this, means due to the electricity, due to the electric force, that will affect your body. So that is why this is made up of plastic. By the way, the topic is the conductors and the insulators. So conductors and the insulators. Okay. Conductors. So basically conductors are the substances in which the electric charge can flow. Hmm? Substances in which electric charge can flow. So these are the substances in which electric charge can flow. For example, just we have seen copper wires and metals. Almost all the metals, metals. We have metals, we have non-metals, we have metalloids also. So basically, there are metals and there are non-metals also. So almost all the metals are good conductors of electricity, or they are the conductors. Means in which the charge can flow or current can flow. All metals like copper, aluminium, etc. For one more example, you can take human body is also the conductor of electricity. Okay. Insulators. So for the insulators, you can say substances in which the electric charge cannot flow. Simple. Substances in which electric charge cannot flow. For example, plastics. You can see here. This is the insulator. This is a plastic case. This is the insulator, and this is the copper conductor. This is the plastic cover insulator. So, for example, plastics, glass, wood, etc. Okay, in this wire there is a current right now. You can see the lighting of this mouse. So in this wire there is a current, but that current is not affecting me. Why? Because the cover of this wire is insulator. Means through the insulator the current cannot flow. That is why my body is not getting affected. So what is the reason behind some are the conductors and some are the insulator? Basically, when you will see the structure of the atom, in the structure of atom, what is there? Suppose this the atom, spherical atom is spherical, we assume. At the center there is the nucleus, and here electrons are revolving. These are the electrons. So this nucleus is positively charged and electron is negatively charged. So there is a force of attraction between the nucleus and the electrons. But the metals, in the metals, there are the free electrons. There are the free electrons. Actually, what happens now? In metals, uh, electrons are loosely, some of the electrons, not all the, some of the electrons are loosely held by the nucleus. Means you can say the force of attraction between the electrons and the nucleus is less. So you can say in metals, the some electrons are loosely held by the nucleus. So those electrons which are loosely held by the nucleus is known as the free electrons. And due to those free electrons in a conductor, okay, in a conductor, due to those free electrons, the current can flow in the conductor. Okay, so I am writing the reason why some are insulators, some are conductors. So what happens in metals? So in metals, there are free electrons. There are free electrons. What is the meaning of the free electrons? Loosely held by the nucleus. Loosely held by nucleus. So these are the free electrons. And these free electrons are responsible for the current to flow through the conductor. Okay. In insulators, so metals means you can say conductors also. In conductors, there are free electrons. In insulators, there are no free electrons. Why there are no free electrons? Because the electrons in the insulator are tightly held by the nucleus. Because the electrons because the electrons in insulator are tightly held by nucleus, and free electrons are responsible for the current to flow. Okay. One more point I want to write. These are the free electrons that are responsible for the current to flow. So free electrons are responsible for the current or charge to flow in, or you can say through a substance. If the substance have the, in simple words you can say, if the substance have the free electrons, then you can say that substance will be conductor. If the substance do not have the free electron, the substance will be insulator. Free electrons are responsible for the current to flow through substance. Through substance. Okay, wait for a minute. Till then, you can note down this.
Atoms.
Aman and Abdullah and Hamla completed this.
Yes, sir. Completed.
Okay, so write down this. So basically, if in any substance there are free electrons, then that will be a conductor. If there are no free electrons, it means that that will be a insulator. And why there are free electrons in some substances, and why there are no free electron in another substances? Because in some of the substances, the force of attraction, or you can say the electrons are loosely held by the nucleus, or in another substances, when where there are no free electrons, the electrons are tightly held by the nucleus. Okay. After this, we will discuss the electric potential. Okay, electric potential. Completed, Martin, Aman, Hamna, Abdullah.
Yes, sir.
Yes, sir.
Okay. So we will discuss now. Actually, I think we should do one question. Means we should try to solve this. Read the question, all of you. Can anyone tell me the answer of this question? Anyone?
Because copper has free electrons.
Hmm? Hmm.
Because copper has free electrons and copper doesn't.
Right answer. The question is, the atoms of copper contain electrons, and the atoms of the rubber also contains electron, because rubber is also made up of atom. Copper copper will also have the atom. Everything is made up of atom, then copper will also made up of atom. So if it is made up of atom, it will have electron. Copper will have electron. Then rubber will also have the electrons.
No, sir. It depends upon the atom,
No,
sir.
beta, you are right. You are right. But here we are talking about the rubber and the copper. Okay. Okay.
Okay, sir.
So in this case, the rubber will also have the electron and copper will also have the electron. Generally, na, we say, I am not talking about the chemistry, means specific case when there is an atom and in that atom there is no electron. One electron you have somehow removed by ionization. That is not I am discussing here. We are discussing the case if there is an atom, electron in an atom. Generally, we say there are electrons and protons. So the thing is that. Then they are asking, then why does the copper conduct electricity but the rubber does not conduct electricity? And what is the reason some substance conducts electricity? Just now I have told you, free electrons. So you can say in copper, the electrons are loosely held by the nucleus. Some of the electrons are loosely held by the nucleus. So it have the free electrons, and free electrons are responsible for the current to flow, and vice versa, or you can say in the rubber, there are no free electrons. Why there are no free electrons? If someone is asking, the electrons of outermost shell, or you can say some of the electrons. We are not discussing the chemistry, so we can say some of the electrons are tightly held by the nucleus. So rubber do not have the free electrons, so it cannot conduct the electricity, or it is the insulator. You can say. Now we'll discuss the potential difference and the electric potential. So first we know what is the electric potential. Now I am sitting here in this room. So there is the gravity. Gravity means gravitational field. Gravitational field is there now. We are in the gravitational field. In the 9th class, I think you have studied the Newton's law of gravitation. So there is a gravitational field, and gravitational field exists due to the masses. Gravitational field exists due to the masses. There is one more field, electric field, and the electric field exists due to the charge. Remember this point. Remember this point. For example, suppose here is a charge. Here is a plus Q charge. Okay. Here is a plus Q charge. And when you will go in the higher classes, in 12th class, you will go. So there you will study that around a charge, the charge creates the electric field. The charge creates the electric field. So this is the charge, and this charge will create the electric field around it. Okay. So we are assuming that here, around it, there is the electric field. Point. Suppose here is one point. This point is suppose P. I am just telling you what is the electric potential. And due to this charge Q, there will be the electric field also at point P. In 12th class, you will calculate also KQ by R square will be the electric field. I am not going in that. What is the electric potential now? Suppose there is a small positive charge, and due to here is the charge, na? Here is the charge, and this is the positive charge. In terms of charge, I can explain you. In terms of the electric field also, I can explain you. But I want to explain you in terms of charge. What is the electric potential? This is a positive charge, and this charge is at very large distance. This charge is at infinite. Just wait and see. This charge is at infinite right now, and there is one here charge, and this is a positive charge, and this is also the positive charge. When and here is one point. When you are just trying to take this charge from infinite to this point, so during this motion, This is a positive charge, this is a positive charge, and what I have told you, positive and positive will repel. There will be the force of repulsion on this charge due to this charge. So this charge will try to repel this charge. So we have to do some work. We have to apply some force, or we have to do some work to move this charge from infinite to this position. Is it or not, Matthew?
Yes, sir.
Hmm?
Yes, sir.
Okay. Suppose you are just uh, moving this charge from the infinite to this position, and the amount of work that you are doing in this process, this work done will be equal to the electric potential at point P. Okay, so this is the electric potential, and this charge will create the electric field. Okay, this charge is the source of electric field, you can say. Source of electric field. So here there will be the electric field also. In terms of the electric field, you can say here will be the electric field, and due to the electric field, this charge will experience some force, and due to that you have to do some external work in moving this charge from infinity to this point. Okay. So the definition of the electric potential you can write the electric potential at a point the electric potential or simply sometimes we say electric potential as potential only. At a point, and that point here is point P. At a point in an electric field, in an electric field, and I have told you due to this charge there will be the electric field around it. So this point P also will be in the electric field. Okay, and this charge Q will also will be in the electric field of this charge. Okay, the electric field, electric potential, or the potential at a point in an electric field is defined as the work done in moving, or you can say in bringing also, in moving a unit positive charge from infinite, from infinity to that point, to that point. Okay, so the electric potential is the amount of work done in moving the charge from the infinite position to the specific position where you want to find the electric potential. Okay, so this is the electric potential. Now potential difference. What is potential difference? Talking about the unit of potential, it is volt, but there is a term potential difference. Most commonly we use the potential difference. Potential difference. And this potential difference is also known as voltage. And this is represented by V. Now what is this? This is one point and this is another point. Suppose this point is A and this point is B. So the potential at point A is VA. Suppose the potential at point B is VB. Electric potential at point A is VA and electric potential at point B is VB. Potential difference means the simply VB minus VA. Okay, potential difference simply means VB minus VA. Now potential difference between 2 points can be defined as, if you are taking a charge from this point to this point, and in taking that charge you have to do some work, and that work is equal to the potential difference. Okay, suppose from this point to this point you are taking a charge and you have to do the work. This work done will be the potential difference, that will be VB minus VA. And what is VB minus VA? VB is the potential at point B, VA is the potential at point A, and this is known as the potential difference. So potential difference in terms of work, how can we write? So potential difference between 2 points is equal to work done in moving a charge between 2 points divided by the amount of charge you are moving. And this potential difference we will represent with V. So you can write V is equal to W, and charge I will represent with Q. Okay. Charge I will represent with Q. So in numerical we will use this formula again and again. Unit of the voltage or the potential difference, SI unit, is volts. One more thing you have to remember, there is, if it is written as 1 small m and volt, this is known as 1 millivolt. In 1 millivolt there are 10 to the power minus 3 volts. Okay, if it is written that 10 microvolt, so it is 10 to the power minus 6 volt. Like we say na, in 1 meter there is 100 centimeter. So if it is written that 1 centimeter, so what you write? 10 to the power minus 2 meter. So in 1 volt there are 10 to the power 6 microvolt. Okay, write down. Done, Matthew, Aman,
Yes, sir. Yes, sir.
and Hamna and Abdullah. Okay, Hamna completed. So electric potential and potential difference. Write down potential difference. Remember, this formula is very, very important, and you should know what is the work, because there is one more work. Force into displacement is also the work. Here is another type of work. Okay. So this is the work that you are doing in moving a charge from one position to another position, having different potentials. After this, now we will solve some of the numericals. Then you will understand properly what is happening. So remember what I have told you. If you are taking a charge from one position to another position, and two different positions can have different potentials also, not the potential difference. They have different potential. When you are taking a charge from one potential to another potential, you have to do the work, and that work I will tell you later. Completed?
Yeah, yes.
Completed, Matthew and Hamna
Yes,
and
sir.
Aman?
Yes, sir.
Done. Okay, fine. Remember, V is equal to W by Q. V is equal to W by Q. What is V? V is the potential difference. V is the potential difference. W is the work done in taking a charge Q. First question. Mm, mm. Very easy question. State the relation between the potential difference, work done, and the charge moved. So you can do it by yourself. No problem. What is the difference? Potential difference is equal to work done in moving a charge and divided by that charge. What is V? V is the potential difference. W is the work done. You can write by yourself that. Q is the charge. Small q. I will represent charge with a small q. Now this is answer number A. Answer number B. Answer number B. Calculate work done in moving a charge of 4 coulomb from a point at 220 volts to another point at 230 volts. Basically, they are saying there is one point and there is another point. Okay, and this one point is at a 220 volt and another point is at a 230 volt. Suppose this point is A, this point is B, and you have to take a charge from this point to this point. Okay, from this point to this point, suppose q charge you are taking. Q is equal to what charge given? 4 coulomb of charge you are taking. 4 coulomb charge you are taking from A point to B point. You have to find the work done. What amount of work done you have to do in moving a charge from this point to this point. So we know potential difference. Potential difference. This is not the potential. This V is the potential difference. Potential difference is equal to the work done divided by the charge. Okay. Work done in moving the charge divided by the charge. So what is the potential difference? 230 minus 220. 230 volt minus 220 volt. Work done divided by what is charge? Charge is 4 coulomb. So it is 10 into 40. 10 into 4. So work done will be 40. Now unit of work is joule. Okay, unit of work is joules. Okay, so write down. Just a minute, just a minute. Okay, write down. It's a very easy question. Again, I am saying this V is the potential difference or voltage. This is not the potential. So in lab now, when you will go in your lab, school lab, so there maybe you will see there is a device, voltmeter. Aman, have you seen the voltmeter?
Yes, sir.
And there is one more device, ammeter. Basically, there are many devices in the lab, but I am talking about the voltmeter only and ammeter also. There is one device, ammeter and voltmeter. So basically, completed now this. Like to measure the weight, there are weighing machines, and there are another machines also to measure the weight. To measure the blood pressure, there are the blood pressure measuring machines. To measure the temperature, thermometers are there. There are different types of thermometer now available. Sensor based thermometer, mercury based thermometer. In the same way, to measure the potential, not the potential, I am saying to measure the potential difference, to measure the potential difference, we use a device voltmeter. So voltmeter is used to measure the potential difference. Completed all of you?
Yes, sir.
Aman? Hamna? Completed?
Yes.
Okay. And what about you, Hamna? You can write in the chat box. You can write only small d. I will understand you have completed. Okay. So for measuring the what potential difference, voltmeter is used. So you can write potential difference can be measured by a device known as voltmeter, a device known as voltmeter. Uh, where is my voltmeter? Hmm. Hmm. So the voltmeter looks like this, something like this. So this is the actually what the voltmeter is. Basically, this is the meter here. Uh, this needle will show deflection, and due to that deflection, we can measure the potential difference. And you will connect here one wire and connect here another means terminal or wire. Now how we will use this voltmeter to uh, measure the potential difference. How we will use this? See, suppose this is a wire. For example, uh, this is a wire, okay, or it will be a conductor because like this. And here now there is one bulb connected. Do you know resistance, Aman? Hmm? This is a bulb. Okay, so this is a bulb and this is the wire, and this is one point. Suppose this is point A and this is another point. This is point B. So now this bulb is glowing, and this, what is this? This is the wire, and you want to measure the potential difference across this bulb, or you can say you want to measure the potential difference between point A and B, then what you will do now? You will connect a voltmeter like this. You will connect a voltmeter like this is the voltmeter. Basically, this connection is known as the parallel connection. We will discuss this when we will discuss series and parallel combination. Okay, you will get to know. So remember, voltmeter is connected in parallel. Voltmeter is connected in parallel. To measure the potential difference between 2 points. And one more thing I want to tell you, voltmeter have high resistance. Voltmeter have high resistance. You can ask me why high resistance. High resistance of voltmeter is because we will study Ohm's law, V is equal to IR. We will study there. So basically, if for a given current, if the resistance is large, then the potential difference will be large. So this voltmeter is measuring the potential difference. So here it is required that the maximum amount of potential drop should be there, so that it can measure the potential difference correctly. There should be no error in measurement. Okay, so you can just write down potential difference is measured by a device known as the voltmeter. And here you can see how you will connect the voltmeter. And they can ask you in exam how you will connect the voltmeter, show by diagram. So this is the diagram to connect the voltmeter. Okay, write down. Martin.
Yeah, writing down.
Okay.